Today, we're going to keep going over derivative stuff. We're going to continue our quest of shortcuts to differentiation. Right now, we've got two kind of base model derivatives, the derivative of a power function and the derivative of an exponential function. When the variable is the base and the constant is the exponents, we have a power function, and the derivative of x to the n is nx to the n minus 1. This was our big rule, because this covers a lot of our algebraic stuff. So this covers our square roots, our negative exponents. So this power function is very versatile. So if we make the variable the exponents and the constant the base, then we have an exponential function. So the derivative of an exponential function, also very useful. But we need some more base derivatives. We're going to build on that today. We're going to add some more basic derivatives. Now, we look at combinations of these basic derivatives with the product rule, quotient rule, and chain rule, depending on whether we have these base derivatives in a product, a quotient, or a composition. All right. Our goal today is to add some more basic derivatives and then see how they work in the product rule, quotient rule, and chain rule. So today, we want to look at derivatives of trigonometric functions. Today, we're going to find some derivatives of trigonometric functions, specifically the derivative of sine and the derivative of cosine. Let's just write down what they are, and then we can think about their graphs and what this means later. But the derivative of sine is equal to cosine. I should say the derivative of sine of x is equal to the cosine of x, and the derivative of cosine x is minus 1 times the sine of x. Derivative of sine is cosine. The derivative of cosine is negative sine. This we can add to our list of basic derivatives. And then we can start throwing these in combinations to use product rule, quotient rule, and chain rule. So let's start some death by examples. Oops, I wanted to write example. Fixed. So let's say we want to find the derivative of, let's say f of x is 5 plus cosine x. In this case, the 5 is included as a constant term. So I want to review some of our other rules. So the derivative of a constant term is 0. So the derivative of 5 is 0. The derivative of cosine x is minus sine x. Oops, these are not equal. So f prime of x is minus cosine. So the derivative of f of x, the derivative of 5 is 0. The derivative of cosine is minus sine x. We want to remember that the derivative of a constant term is equal to 0. If we have a constant multiple, that just carries along. So, for example, let's say g of x is 5 times the cosine x. So instead of 5 plus cosine x, we have 5 times cosine x. We know the derivative of a constant times a function is that constant times the derivative of the function. So we can just say, keep the constant multiples. So if we have a constant factor, that just gets carried along. So g prime of x is 5, and then the derivative of cosine x is negative sine x.
Professor, I have a question.
Uh-huh.
So if instead of a 5, we have like, let's say x, so we would have like x times cosine of x, and then we would have to use product rule for that, right? So how come when it's a constant, we do not need to use the product rule?
The derivative of a constant is equal to 0. So if we use the product rule on 5 cosine x, if I say the first is 5, then the derivative of the first is 0. And that's going to take out that first term. And if the second is cosine x, then the derivative of the second is minus sine x. So g prime with the product rule would be the derivative of the first times the second, plus the first times the derivative of the second. So we kind of are using the product rule, but we're recognizing that if one of the factors is constant, then one of the terms in the product rule is going to be 0.
So even if we use the product rule, we would still get the same thing.
Correct.
Okay, that makes sense. Cool.
So let's take the 5 and move the 5 on the other side of cosine. Right now, the order of operations is in 5 cosine x is to take start with x, find the cosine of x, multiply the result by 5. Let's switch that order of operations. So let's switch that order of operations, and let's say h of x is the cosine of 5x. So now the first thing that happens to x is we multiply by 5, then we find the cosine of the result. So the way we want to read this problem is not that 5 is a constant multiple of the function cosine x. We wouldn't want to read this as a product. We need to read this as a composition. So here we need to identify 5x. This is the first thing that happens to x. So I'm going to say the inside is 5x. And that leaves the outside to be cosine. So for this function h of x, we take the derivative of cosine of a thing is negative sine of that thing times the derivative of the thing. So the derivative of cosine of 5x is negative sine of 5x times the derivative of 5x, which is 5. This would be a crazy way to write it with the constants at the end. So I have minus 5 sine 5x. In the previous problem, the order of operations was different. In g of x, the order of operations was find the cosine of x and multiply the result by 5. With h of x, the order of operations says first multiply 5, then find the cosine of the result. So that changed the problem from a product rule to a quotient, a chain rule, a composition. If I have another variation still, so for example, let's suppose that capital H of x is 3 times the cosine of 5x. We want to read this as a composition where the 5x is the inside, so that's still the same. The first thing that happens is we multiply by x by 5, then we find the cosine of the result, and so we're taking the derivative. We could set y up as the cosine of u, and then we could mark the 3 as a constant multiple. So the derivative h prime of x, we're going to keep our constant factor. The derivative of cosine of a thing is negative sine of that thing. And that thing is 5x. So negative sine of 5x times the derivative of the inside, which is 5. This would be a crazy way to write it with the 3 and the 5 all split up and this 5 extra constant at the end. So I'm just going to gather it up. 3 times 5 is 15 times the sine of 5x. So like I was mentioning yesterday, this is a reading exercise. We have to learn what these functions are saying. We don't want to learn a bunch of tricks based on form. There's reasons for the order that we do things. And that relies on our ability to read what the function is telling us to do, what the order of operations is on this function.
Professor?
Yeah.
So if we ever encounter a problem, let's say like in which we have to use the product rule and the chain rule, which one should we do first?
Whichever one you need to do first, you do first. It has to do with the order of the operations. So there's no hard and fast rule. We can write a problem where you need to do the product rule first, and we can write another problem where you need to do the chain rule first. It depends on what the function is telling you. Let's look at an example.
Oh, Professor Rich, just a quick question, please.
Mm-hmm.
The first two example here, this is the chain rule, isn't it? Away right now?
We use the chain rule in both of these problems.
Yes, okay, got it, thank you.
So let's look at another function. Let's suppose that p of x is 3x squared times the cosine of 5x. So we see a lot of things going on. There's a function of x, the 3x squared. There's a cosine of 5x, which makes it where we know we have to use the chain rule. So the question is, which thing do we do first? If we look at what's going on, there's a product. I have to find x and then square it. And then I've got to go over to this other function, take the x, multiply by 5, and find the cosine of the results, and then multiply those two, the result of x squared and the result of cosine of 5x. This tells me I need to do a product rule because I've got a product of two functions. Because I've got to do this first piece, 3x squared, put that aside while I go over here and do cosine of 5x, work that out, and then multiply those two results. So that tells me product rule. So our first function Yeah, our first is a 3x squared. And our second will be cosine of 5x. Now we need the derivative of the first. The derivative of 3x squared is 6x to the first. And the derivative of the second, the derivative of cosine of 5x is negative 5 sine 5 of negative 5 sine of 5x. Just using the result that we had before. So notice when we took the derivative of the second, we needed the chain rule, but just for that derivative of that factor. So we did use the chain rule. So we're using the chain rule for part of our product rule. Now we can put together in the product rule formula for p prime of x, where we take the derivative of the first times the second plus the first times the derivative of the second and then we should simplify. Note that this set of parentheses around the negative 5 sine of 5x is really important because this factor is negative. If you leave off this parenthesis, it'll look like 3 terms, but there are only 2 terms. So we'll have 6x cosine of 5x, and we should clean up our constants over here. 3 times negative 5 is negative 15. X squared times the sine of 5x. This only seems like a lot to remember because it's a lot to remember, and you have to remember all of it all the time in perfect detail. Because here we had to read that this was a product rule, then we had to remember to do the chain rule as part of the product rule. We are using the chain rule as part of the product rule. So let's look at some more examples. Once again, it's a reading exercise. So let's say that q of x is 3 times cosine squared of 5x. So once again, this is a reading exercise. We got to know what we mean when we write cosine squared of 5x. When we write the exponent after the cosine and before the argument of cosine, what we mean is find the cosine of 5x and then square the result. So this is a big stack of chain rule. It's not even a big stack of chain rule. It's just 2 chain rules. We've got 5x inside a cosine and the cosine of 5x inside of a square. So we got to make sure that we read what we mean when we write cosine squared 5x. This means 3 times the cosine of 5x squared. Five x is inside the cosine. Cosine of 5x is inside the square. So our inside is cosine of 5x, and that's inside the square. So I would say u is cosine of 5x. And our outside function, y is u squared. So the derivative of something squared is 2 times that thing times the derivative of the thing. So q prime of x. The derivative of 3 times something squared, I should maybe, 3 is a constant factor. So the derivative of 3 times u squared is going to be 3. The derivative of something squared is 2 times that thing to the first power. And then we have to multiply by the derivative of that thing. And the derivative of cosine of 5x is negative 5 sine of 5x, based on our first example on this page, based on this example way up here. So the derivative of cosine of 5x is negative 5 times the sine of 5x. What's going on in this piece is that the inside is like a 5x, a different u is 5x, and our second y is cosine of u. The derivative of cosine of u is negative sine of u, and the derivative of the 5x of the u is the 5. I should color code this 5. Now, this is a complete mess with this negative dangerously in the middle of our function, and all these constants not multiplied together. So I got a 3, a 2, and a 5. That's all multiplied together to get 30. We still have this negative, so negative 30 times cosine of 5x. I spelled cosine wrong. Times the sine of 5x. Like I said, this only seems like a lot to remember because it's a lot to remember. And you have to remember all of it, all the time, in perfect detail. And this does not only include the calculus rules that we're trying to learn, but also the algebra rules that we're trying to remember. Let's look at some more examples. Let's suppose that q of x is 3 x squared times cosine to the 4th of 5x. In the previous problem, we just had cosine squared, 3 cosine squared of 5x. It was just a bunch of chain rules. What's the first rule? What's the first rule that we're going to apply to find q prime of x? We see a similar structure to what we had before. We've got a cosine to the 4th of 5x. We should remind ourselves what that means. So 3x squared is just 3x squared. But cosine to the 4th of 5x means cosine of 5x to the 4th power. We just got to get used to reading cosine to the 4th of 5x as cosine of the 4th power of the cosine of 5x. We got to be very careful about how we say things. Because a lot of times in an algebraic expression, I can write it down, ask you to read it to me, and I can, it might be written down wrong. That's why math is a very precise language. So I wouldn't want to read cosine to the fourth of 5x as cosine of 5x to the fourth, because if I just said cosine of 5x to the fourth, is x being raised to the fourth? Or is the product 5x being raised to the fourth? Or do we mean the fourth power of the cosine of the product of 5 and x? Anyway, in this problem, we're going to have to use the chain rule on this cosine of 5, the fourth power of the cosine of the product of 5 and x. But once we have, think of it in terms of what you're evaluating. I first would plug x into 3x squared, and I would have to keep that result off to the side while I worked on x times 5, then find the cosine, raise the result to the fourth power, then multiply those two results together. So that tells me that what's going on here is a product rule. And so I need to identify a first, which will be 3x squared, and a second, which will be a cosine of 5x to the fourth power. Incidentally, if you're working on your reading, when you say cosine of 5x all to the fourth power, that doesn't help anything at all. Is the all the 5x, or is the all the cosine of 5x? And if that's what you're going to do, how do you read cosine of 5x when it's just the 5x being raised to the fourth power? I guess what I'm saying is that we need to learn how to read math and then speak it properly. So if the first is 3x squared, then the derivative of the first is 6x. And if the second is the cosine of 5x to the fourth, then the derivative of the second the chain rule, we can think, one way to think about the chain rule is that the chain rule works outside in. The first thing that happens to x is we multiply by 5, then we find the cosine of the result, then we raise the result to the fourth power. The chain rule kind of works from outside to in. Take the derivative of the outside with respect to the inside, then multiply by the derivative of the inside. So the derivative of the fourth power of the cosine of the product of 5 and x will be 4 times cosine of 5x to the third. And then we have to multiply by the derivative of the inside. The derivative of cosine of 5x is negative sine of 5x. And then we have to multiply by the derivative of the inside, which is 5. So we had to stack a couple of chain rules together. Take the derivative of the outside with respect to the inside, multiply by the derivative of the inside. Now this is just the derivative of the second. We should clean this up because it's kind of a mess right now. So the derivative of the second, I've got a 4, a negative sign, and a 5. So I'm going to write this as negative 20 times cosine cubed of 5x times the sine of 5x. All this is the derivative of the second. Now I've got my 4 parts. I got the first, the derivative of the first, the second, and the derivative of the second. I can write q prime with the product rule. Product rule says take the derivative of the first times the second, so 6x, times the derivative of the first times the second, which is cosine of the fourth, of 5x plus the first 3x squared times the derivative of the second. Derivative of the second has a negative factor, so I'm going to put it in parentheses. This would be a terrible state to leave your factors in with all these the constants all split up. So I'm just going to put these factors together. So I'm going to, first term is fine. I'll just write it as 6x cosine to the fourth of 5x. And then 3x squared times negative 20 will be negative 60x squared cosine cubed 5x times the sine of 5x. Most important thing about doing these kinds of problems is that you keep yourself organized. And if you get to the end and you think you've made a mistake somewhere, it's really important that you don't just try to pick out where the mistake is and then correct it moving forward. Just cross it all out and start over again. It's important. I always used to tell people that you need to do math in pencil. But the problem is, if you use a pencil, you start erasing the most important part of the process, and that's making mistakes. So that when you go back and look at your work, if you've erased all of your mistakes, you're just looking at this nice, clean example. And then you pretend that that came out that way. And it's like, oh man, I got this one right on the first time, and you ignore all the mistakes that you made. So when you go back to study, it's not helpful. That problem doesn't, you have to remember that you struggled on a particular problem. But if you do the problems in pen and you just have to scratch all this out and then start over down here, when you come back to review this problem, you'll say, oh man, look how many times I had to do this problem. This one took a lot of work. I better check this one out again. What kind of mistakes was I making? Why did I make those mistakes? All too often, as students, we just want the process to stop. And so as soon as we get the right answer, we say, okay, I understand that one, which is the big lie that we tell ourselves. We get a problem correct, and then we think, oh, good, I understand this now. And your thinking is, I've done this once successfully. Ignore the previous 5 tries. And therefore, I understand it. That would be like stepping out on a basketball court, sinking one basket and say, I understand this now. I'm good at this. Because that's just not how it works. You don't get to be good at it until you've done it thousands of times. Any questions? Let's change things up a little bit more. So in this one, I had 3x squared times the cosine to the fourth of 5x, a product rule with some chain rule inside it. Let's suppose that r of x we're still going to have a 3, and we're still going to have a cosine to the fourth. But instead of 5x, we're going to have a 5x squared. I'm moving the square inside. And we're going to multiply the 5x times e to the negative 1x. This is obviously a super useful equation that you're going to use all the time in your career as a future fill in the blank. Or this is just an exercise to help us learn to read functions. I think it's more of the latter. Because the only time I run into this particular function is when I teach Calc 1 in the fall and we come across product rule, quotient rule, chain rule. Earlier, the question came up, which one do we do first, the chain rule or the product rule? The answer is it depends. Gonna have to quote legal at this point. The answer is it depends, as usual. It depends on how the function is set up. Note that we have a product in this problem, but it's also a chain rule problem. So we've got to think about what's going on. Let's think about what happens to x. First, I take x and plug it into the 5x squared, and I put that result aside so that I can go over here and do e to the negative x, and then multiply those two results. Then that stuff gets put into the cosine, and then the result gets put into the fourth power. So this product rule happens before cosine. So we're going to use a product rule on the derivative of the inside. And I decided to make this problem extra complicated by putting the cosine to the fourth. So it's the second inside that we're going to be dealing with, the product rule. Because once again, we are going to read cosine to the fourth as the cosine of 5x squared times e to the negative x to the fourth power. So in this problem, we're going to do the chain rule for 3 something to the fourth. But when we get to the times the derivative of the inside is going to be the cosine of this stuff. The derivative of cosine is negative sine of the stuff times the derivative of this stuff. And when we get to there, that second application of the chain rule, that's when the product rule shows up. So r prime of x. I'm going to start off with 3 thing to the fourth power. The derivative of 3 times this stuff to the fourth power is 12 times this stuff to the third power. Then I multiply by the derivative of the inside. So the derivative of this is the inside stuff. The derivative of cosine of all this stuff is negative sine with respect to this inside stuff, 5x squared times e to the negative x, times the derivative of the inside, and the inside is a product rule. So for this product rule, I'm going to have a first. The first will be 5x squared. And our second is an e to the negative x. The product rule requires the derivative of the first, which is 10x. And we'll also need the derivative of the second. The derivative of e to the something is e to that thing times the derivative of that thing. So I have to use the chain rule again as part of the product rule. It started off with the product rule as part of the chain rule, and now I have to use the chain rule as part of the product rule. The derivative of e to the negative x is e to the negative x times the derivative of the inside, which is negative 1, which I will write as negative e to the negative x. I ran out of colors. So I have to multiply by the product rule based on these four parts. I still got this first part. I got 12 times the cosine cubed of 5x squared times e to the negative x times a negative sine of 5x squared times e to the negative x. And then I have to use the product rule. The product rule is the derivative of the first times the second, so 10x e to the negative x plus the first times the derivative of the second This only seems like it's a lot to remember because it's a lot to remember. There was a lot going on in this problem. But all we needed to sort this all out was the product rule and the chain rule and our basic maneuvers. Derivative of power rule, derivative of power function, derivative of exponential function, and the derivative of trig function of a trig function. We should clean this up. This looks terrible with this negative factor in the middle. So this actually looks awful as well. Let's first do this. This is negative 12 cosine. Oh, I'd already done this. 5x squared e to the negative x times a sine of 5x squared e to the negative x. And then I have two terms here. I've got 10x e to the negative x minus, this is what I wanted to clean up here, 5x squared e to the negative x. So notice I've got these two terms here. This would be acceptable. All of our constants for this these outer factors are gathered in front of the outer factor, and this term is simplified. All the constants are moved into the front of each term. So this I would consider good enough. If you want to factor further, notice that this third factor, the one with the two terms, has a common factor of a 5x and an e to the negative x. So it might be that we look at this factor and say, I want to clean this up even more because I have two instances of this x e to the x. So I'm going to factor a 5 x e to the negative x out of these two factors, just these two. I can't do it out of these first, the cosine and sine factors. And that would leave a 2 minus x. Now I'm just taking these two factors and factoring out the 5, an x, and an e to the minus x. Now I have this factor of 5x e to the minus x. I can write that in front. And maybe the factored form should look like negative 60 x e to the negative x times the cosine cubed of 5x squared e to the negative x times the sine of 5x squared e to the negative x times this factor 2 minus x. I wouldn't require that you factor this last piece out because the previous one has a reasonable amount of cleanup with the negative being multiplied and this negative being multiplied. And so this would be kind of an excessive amount of cleanup.
Why is the 60 negative?
Because this negative in front of the sign got moved out into front of the negative 12. Negative 12 times 5 is negative 60. I see in the chat, some of us are down to our last 2 brain cells. Don't worry, I've been operating on 2 brain cells for a very long time. You can get by.
Wait, Professor. So I noticed that in the sine 5x squared times e to the negative x, don't we need to use like the chain rule for that as well?
We did. The derivative of cosine of this stuff was negative sine of that stuff. And these 2 terms from the product rule, that's the derivative of the inside here.
Oh, so the third term is the chain. Okay.
The third factor.
Okay.
This is the third factor. Here's the first factor, 12 cosine cubed. The second factor is the negative sine. The third factor is these 2 terms. Factors are things that are being multiplied. Terms are things that are being added.
Okay.
I make that distinction because different rules apply to factors as apply to terms. Any questions? How's everybody okay? If at this point you're thinking, man, this is overwhelming, I'm never going to remember all of this. That is the correct answer. That is how you are supposed to feel when you first start doing some of the crazier problems. When we first start, I couldn't even fit this all on one page or on one screen and have the closed captioning down here. When you first start doing these problems where I just stack up all these extra rules on you so that you can figure out what order things are supposed to go, you should look at this and think, this is overwhelming. This is just a lot. It's perfectly acceptable to say, this is a lot for me to absorb right now. It is incorrect to say, this is too much for me to absorb, unless you finish that sentence by saying, this is too much for me to absorb right now. Notice the big difference between those. It's totally not too much for you to absorb given time. It just takes time and practice. Do thousands of problems and you'll get better at reading your functions.
Professor, I have a question regarding like the homework. So I'm not sure if we were supposed to do that already, but I started doing like the 5.01 and stuff. But I realized that we only have 3 tries for like the problems.
Is this the chapter 5?
Yeah.
The chapter 5 homework you shouldn't start working on. The chapter 5 homework, I didn't even know that shouldn't be released yet.
Oh.
So don't work on chapter 5.
Okay.
Oh, I didn't even realize that was available. I'm going to unpublish that.
I just clicked on assignment and it just gave me like a list of things that I could do, but
yeah, you don't want to do that yet.
That made a lot of sense.
I haven't gone and adjusted those to be unlimited attempts.
So do we have any homework that we could do yesterday?
Yeah, there's currently, I put up another section, another bunch of assignments from chapter 3. So if you check in the modules, there will be another set of assignments that are due on September 19th. And then there's some more assignments that will be due on September 26th.
Okay, I see it.
Right now, your job is going to be to learn your basic derivatives and practice using the product rule, quotient rule, and chain rule. All right. I'm gonna have to work on that homework problem tomorrow because we're out of time. So that's gonna do it for today.
Thanks,
That's
Professor.
gonna do it for today. I'll see you all on tomorrow. Everybody have a good day, and thanks for playing.